Okay, hello. Happy Wednesday. Good evening. Hi, Sintong. This is our September week 3. Okay, how are you? So, okay, anyway, let's continue. So, 我们在哪里嘞? We were at chapter 9. Okay, we finished halfway through polymer, right? 这个讲到一半哈 polymer 哈 Okay, do you remember this? Do you remember what is a polymer? Okay, just a fast reminder. We learned this last week. When you take one Lego is a monomer. And when you join many monomer together, okay, you join many together, you will get a polymer. Okay, mono means one, 一个 poly means many, 很多个 Okay, so we have natural polymer. Okay, and we have synthetic polymer, 人造. Okay, so natural polymer is like your glucose and starch. Okay, one glucose, many glucose is starch. One amino acid, many amino acid is protein. One isoprene, many isoprene is rubber. Okay, this is our focus later. We are learning rubber today. Okay, and of course, what is synthetic polymer? Synthetic polymer is mostly your plastic. Okay, your plastic. Okay, polythene, polystyrene, perspex. Okay, all these are your plastic. I think I mentioned this last week, to join, did I talk about it? 这个我有讲吗? To join all the monomers together, okay, let's say all these monomers, you join them together, we call this polymerization. Polymerization, okay, polymer, I change it to polymer, so polymerization. Okay, polymerization, polymer 化. Okay, you see, I colorize something, means I make something to have color. Colorize, 颜色化. Polymerize, polymer 化. I make something to be polymer. So the reverse, we call it depolymerization. D means reverse. You know, activate, deactivate, 激活, 取消. Okay, activate, deactivate. Okay, simple, simple, nothing much to say here. Okay, this one quite important, so pay attention to this, highlight for you. Okay, so next, shall we go to the next one? Shall we go to the next one? Okay, today we will talk about rubber. So can you please put a star here? Rubber. 这个会出在 essay. This is coming out for essay, so please pay attention here. Okay, so you know what is a rubber, right? Rubber is your 香蕉. Okay, you know rubber comes from a tree. Okay, rubber tree, 香蕉树. Okay, so when you cut a rubber tree, when you tap a rubber tree, you will get something called latex. Okay, latex. You remember what is latex? Latex is your 乳胶. Rubber tree latex. This is your latex. See? Can you see the lines? They cut the tree. So they cut the tree, they will let the thing drip. 这个就是个胶咯. So this is your latex. Okay, the milky white substance is the latex. When they harden, they become rubber. Okay 吗？它硬了就变 rubber. So the liquid is latex. Okay, 乳胶. Okay, anyway, so let's look at, okay, see, latex is then processed into natural rubber. Latex will become rubber. Okay, so characteristic of rubber. Okay, I'm sure you know. Okay, think about a rubber band. Okay, rubber, think about your latex glove. You know latex glove? Latex glove. Your 手套. I'm sure you know this lah. Okay, latex glove. Okay, so think of them as elastic. You see, latex glove is very elastic. They are very soft. Okay, not permeable to air. What is this? 这个是不透风，不透气。That means air cannot go into rubber. If you wear something rubber, it feels very stuffy. Okay, 很不透气. Okay, it's not like your you see your t-shirt air can go in, but this one rubber air cannot go in. Cannot withstand heat. Okay, you see rubber they don't like heat. Okay, rubber they don't like heat. So if you use your glove to hold anything hot, the thing will start to break, will start to melt. Okay, rubber and heat they are not good friends, and of course they are good electrical insulator. 它们是很好的绝缘体. Okay, good electrical insulator. That means rubber can stop electricity. That's why we use it for our shoe. Okay, you know, if you work for TNB, if you work for TNB, you need to buy shoes like this. You need to buy shoes like this. There, we call it electrical safety shoe. Why? Because, okay, you might say, sir, our shoe, normal shoe cannot make, can, but it's not as good as this shoe. This shoe is really thick and it's all rubber. Okay, not very comfortable to wear, but this thing can tahan a lot of electricity. So you won't get electrocuted. 不会被电死. Okay, so you see, rubber is a very good insulator. Okay, huh? Okay, so what I want you to pay attention today is here. Okay, it's here. If you zoom into that milk latex, 那个乳胶，那个白白色的水if you zoom in you will see something like this. Okay, this is your rubber particle. 你的橡胶分子. Okay, this is one particle, this is another particle. Okay, let me explain what is inside here. The main thing we want is this inside. Can you see this is your rubber polymer? 我们要的橡胶 polymer 就在里面. This is what we want. This is what we want. Okay, this is what we want. This is what we want. So what is what is this outside thing? Can you see there's a membrane protecting your rubber? Can you see this membrane? Can you see there's a protein membrane? 就是一个蛋白质层. Okay, there's a protein membrane. And then outside the membrane, we have negative charge. Okay, you have negative charge. Okay, you see, all this rubber particle has negative charge, right? 全部橡胶分子都有 negative 是吗? Okay, so what happens to negative and negative? What happens when they come close to each other? Negative will do what? Will they attract or will they repel? 他们会吸引还是反弹? Same charge. You learn this in Form 2, I think. Yeah, in your electricity. Okay, do you remember something like this? Positive and negative. They will attract. Yes, they will repel, right? So negative, they will 排斥, repel. Okay, so what will happen when they come close? They will repel. They will bounce off. Because negative, they don't like each other. So is this a good thing? Is this a good thing? Yes, if you're a rubber tapper. 如果你是割胶那个人, okay, if you're a rubber tapper, this is a good thing because this thing will make sure they stay in liquid. Okay, they stay in liquid. Okay, what do I mean? You see, if this negative charge is no more, they will come together and then the protein membrane will break. Okay, and then can you see this inside they clump together? 它们粘在一起. So when this thing happen, right, your rubber will coagulate. Coagulate means 硬化, 凝固. Your latex will turn into rubber. In this case, we call it rubber already. We call it latex already because it's not in liquid anymore. This is solid. This is solid. So if you're a rubber tapper, if you're a worker, this is a very bad thing because now your rubber is useless. Okay, the thing will harden inside the cup. You know the cup just now, it will harden inside, 在杯子里面硬化. This thing will become useless. You cannot sell it, right? So what we want is this. Okay, what we want is this thing to be there. this thing to be there. So they will push away each other. So they will stay in liquid. They will stay as liquid. Okay, huh? So you see, negative charges on the outer surface of membrane. Rubber molecules repel each other. Latex remain in liquid. Okay, so what happens when you add acid? Okay, please copy, please circle this for me, and please write this down for me. Acid is positive. Okay, please add a positive there. Acid is positive. Okay, you see, here comes the problem. Here comes the problem. Okay, when you add acid, okay, you don't need strong acid. You just need ethanoic acid. This is vinegar. You need formic acid, something really weak. These two are very weak acid. Okay, you don't need like hydrochloric or sulfuric, no need. Just weak acid will do. Okay, so you use these two acid, right? You use these two acid, you put it inside here. What happens? Can you see acid is positive? Okay, so what will happen? This positive, negative, they will neutralize. 它们会中和. You see, positive one, negative one, zero. Again, positive one, negative one, zero. So they will cancel each other. Okay, they will cancel each other. So now, this thing will be no charge already. Okay, no charge already. So will they repel each other? No, they will stick together and then they will coagulate. This is the word I want. Coagulate. 凝固. Okay, this thing will harden. Okay, this thing will harden. Okay, so this thing is what they do in the rubber factory. Okay, if let's say I tap rubber already, I sell the latex to the factory. Okay, I sell the latex to the factory. The factory make this latex into, let's say, glove. They want it to harden, right? They want it to become solid, right? So they will add acid. So this thing is a good thing for the factory, but it's a bad thing for a rubber tapper. You get what I mean? Okay, if I sell rubber, if I sell the latex to the factory, if this happens, my latex is worthless. But if I'm a factory, I want this to happen. Okay, so when you add acid, this thing will harden. Okay, so please let me explain how do you write this. Okay, this might come out in essay. Let me say this again. This might come out in essay. 作文会出这个东西. Okay, so just be careful. Okay, so when acid is added, it is positively charged. Okay, it has hydrogen ion. This one you want to write, you write. You don't want to write, it's okay. It will neutralize the negative charge. Rubber molecules will collide. Okay, collide means they 装在一起. Okay, so this will break the protein membrane and the protein now will coagulate. Now, these words that I highlight is the keyword. Is the keyword. I want you to say collide. I want you to say neutralize. I want you to say collide. I want you to say coagulate. Okay. Okay, you know what time they go out to tap rubber? 他们几点出去割胶? Do you know? Last time our grandpa, grandma. Do you know what time they go out? 5, yeah, somewhere around there. Okay, why need to be so early? Why need to be so early? Cannot go out when the sun rises, man. Okay, when the sun comes out, like around 8 or 9, the weather will become warm. Okay, the weather will become warm. So what will happen? The bacteria in air, you know you have bacteria in air, right? So the bacteria will become active because weather hot, the bacteria will become active. So bacteria will produce acid. You see how this thing comes together? If I go out to tap rubber at 8, okay, before I can collect all the latex, this thing will already harden because all the bacteria produce acid and it hardens my rubber. So now my rubber is useless. That's why they have to go out early, very early, before the sun comes out. Okay, you see the sun when it's warmer. Okay, I give you another example. If the weather is really warm, okay, lately it's been raining, right? Okay, but if the weather is really warmer, you will notice your food will spoil very quickly. Have you noticed that? Have you noticed that? If you buy a pack of nasi lemak at 7 a.m. and then you put it on the table, let's say the weather is really hot. Okay, even your house is very warm. You put the nasi lemak on your table, and if you open your nasi lemak at 2 or 3 p.m., you start to smell the nasi lemak is like a bit sour already. We say 臭酸. Okay, the food is now bad because of the bacteria, right? This is exactly why they have to go out very early in the morning so that this acid doesn't happen, this neutralization will not happen, this coagulation will not happen. Okay, can understand? Okay, so how do we stop this from happening? What's the opposite of acid? We add alkali. Okay, so this alkali, you can write this now. This is negative. Just now acid positive, right? Now alkali is negative. Okay, alkali is negative. So this negative will come here. Just now we have acid, right? We have acid, right? From you see from bacteria, right? Okay, never mind. So now I add alkali. This alkali is negative. They will neutralize the acid, and now the whole thing becomes negative again. So my latex is safe. Okay, my latex is safe. So rubber tappers, they will add some alkali into every cup one. Hey, you know those rubber tappers are very gang one. They one morning they get tapped by 200 trees one. Okay, they will tap through 200 trees, and then they will come back. They will collect. Okay, so it's a very hard job lah, very labor intensive lah. So, and you know how much they sell for one bucket of latex? One bucket of latex, you can sell it for one whole morning. You tap one bucket. That bucket you can sell for 2 ringgit, 2 to 3 ringgit. Okay, that's what my friend's grandma told me anyway. Okay, last time they used to tap rubber trees. Hard times, right? A whole morning's work to get 2 ringgit. I mean, last time 2 ringgit is not too bad. It's enough to feed your family for a day Okay, so times were hard. Okay, not like now we so senang already. Okay, anyway, so when alkali is added, the hydroxide. Okay, the hydroxide, this is negative. Okay, the hydroxide, they will neutralize the positive, the hydrogen. So negative charge remain on protein membrane. So they will repel, they do not collide, they will remain in liquid form. Okay, very easy. Hey, in exam, if they ask you to write essay, you can actually draw for them. You can draw it for them. Easy, you draw for them, so you get the marks. No need to explain so much. Okay, acid positive, alkaline negative. Positive will coagulate the latex. Negative will make the latex stay at liquid. Okay, easy, easy, this one nothing much to say on. Okay, so so far okay. So far okay. This is one of the most important part of this chapter, including your alloy. The alloy is most important. This I would say this is second. Okay, good. So moving on. Moving on. Okay, next. What is vulcanization? Okay. You know, just like I said, rubber cannot stand heat, right? Rubber cannot tahan heat, right? Rubber 不耐热嘛. But here's the problem. We use rubber to make something called tire. And just in case you don't know, tire needs to be hot. Tire will get hot, right? I don't know whether you know this. Next time after your dad drives, right, you go and touch the tire, is warm. So how? Then the tire will melt. So you see, this is where this thing comes in. This is what we call vulcanization. Vulcanization means we strengthen the rubber. 这个叫强化. Okay, we strengthen the rubber. So you see, vulcanization can improve the properties of rubber and make it stronger. Okay, so your tire, they are all vulcanized. Your shoe sole, 你的鞋底, it's all vulcanized rubber. You know, Birkenstock, the base is rubber, it's vulcanized rubber. Yeah, so they can last very long. Okay, so this is your your vulcanization. Okay, so how do we do vulcanization? Very easy. We take latex, we hit it with sulfur. We hit it with sulfur. What is sulfur? Sulfur is a yellow color powder. This is called Liu Huang. I don't know whether you see this before. Last time my grandma used to put this around the house to chase snakes away. So this is your sulfur, right? So you put sulfur in. Okay, you put sulfur in. What's gonna happen? Okay, you see, this is natural rubber. This is natural rubber. Can you see? Can you see the polymer is very smooth? Okay, they can easily slide over. See, just like alloy, right? Just like alloy, right? You see, easy to slide. This natural rubber is the same thing. They are easy to slide. Okay, so do we do when we add sulfur? Can you see now I built a bridge already? I built many bridge already. I hold them together. This is what we call sulfur crosslink. Or some books they write sulfur bridge. I accept both. Okay, sulfur bridge. So now this sulfur bridge hold them together. Now the rubber becomes harder. It's vulcanized. So you cannot move them already. No, say cannot, but it's much harder. So this becomes harder and more elastic and stronger. Whereas this one is still very soft. Okay. So this is good quality rubber. This is like not so good quality rubber, very cheap rubber. Okay. Okay, so that's the difference. You know what's your car wiper? You know your car wiper? Do your parents change the wiper consistently, or they just leave it there? So I don't know whether you know this, when it's raining, when your mom or dad switch on the wiper, if the wiper is like making the thing worse, okay, sometimes when you see rain, I need to wipe my window. So when I switch it on, oh my god, I make it even worse, that means the rubber is not good already. Okay, so if you go to DIY, right? If you go to Mr. DIY, they sell you one wiper for $10. Okay, so you got two, so $30, that's the cheap one. And then you look at some branded ones, they're like 30 each side. Why 3 times the price difference? Because the cheap one is usually natural rubber. They won't last a lot. They won't last a long time. 3 months later or 6 months later, the thing will be back to terrible. You cannot see clearly anymore. Your wiper doesn't work well anymore. But if you buy the $30 one, that thing can last like 3 times longer because it's vulcanized. You get what you pay for, lah. You get what you pay for, lah. So if you park your car under the sun, because the sun is very hot, your natural rubber will for sure break down. That's why they don't last for very long. But vulcanized rubber, they will tahan. Okay, they will tahan. So is there anything? Okay, this thing will still break, but much slower. So is there anything better than vulcanized rubber? Yes. Have you heard of silicone? Silicone rubber? Silicone rubber. This is even better. This is even better. Nowadays, we use silicone even more than rubber now, because silicone is like they langsong, not scared of heat. Okay, and you cannot use rubber to transport food because your food will taste like rubber. But silicone rubber is food grade. This thing will never break one. Not say never lah, but it's so much more longer lasting. Silicone rubber. Okay. This is your there. This is so much more longer lasting. And the good thing about silicone is they have no smell. You know, rubber has a smell. You know, latex has a smell. I don't know whether you noticed. Have you been at a tire shop before? Have you been at a tire shop? Okay. Or, you know, every year there's dentists at your school, right? Do you? Do you have dental checkup in your school every year? Maybe yes, okay. The glove the nurse is using is latex. Smelly, right? It has a smell, right? When they're checking your teeth, you can smell the glove. That is latex. Okay, it's really bad. Okay, or if your teacher could ask you to go buy a condom before, okay, because Form 1 we all learn reproduction So if you have seen a condom before, if you play with it, It's really smelly. Okay, silicon has no smell, right? Silicon has no smell. That's why silicon, we can use it to even make food container, make any pipes. I see this thing has no smell and it's so much more longer lasting. This is a new technology lah. This is a new technology already. I mean, we still use rubber because rubber is cheaper. Rubber is cheaper, but silicon rubber is just better. Okay, so there's a sulfur crosslink. It is difficult for the chain to slide over. Okay, difficult to slide over, just like what we said in alloy. Okay, so when heat is applied, they are difficult to break. Okay, they very tahan heat. So you look at the difference of vulcanized rubber and natural rubber. The similarity, they are both polymer, they are both insulator, but the difference is this is every bit better. You see, this is hard, this is soft, more elastic, less elastic, difficult to oxidize, 它不会氧化. This one easy to oxidize, does not react with acid alkali, reacts with acid alkali, not permeable to air, liquid and air cannot go through. This one somehow is a little bit permeable, is resistant to heat, not resistant to heat. So you see, vulcanized is just so much better. That's why we use vulcanized, and it's not much more expensive than natural rubber. So might as well use vulcanized. Your tire is vulcanized rubber for sure. Okay, your tire is vulcanized. Okay, if not, your tire will start melting. When you go on a highway, when you start to go faster, when there's more friction, your tire will start melting. It doesn't happen, isn't it? Because your vulcanized rubber is very long lasting. Okay, so this rubber technology you can don't care lah. It's not our concern. Okay, so that's it for our chapter 9. Let's go to our exercise, shall we? Okay, let's go to our exercise. Can you please go to page 15, question 11. Okay, question 11. Okay, we finished the polymer first lah. So what is a polymer? A polymer is a chain of repeated unit of monomer. I repeat my monomer, I get a polymer. So there are two types of polymer. We have natural polymer and synthetic polymer. The natural one and the man-made one. Okay, so what polymer is naturally natural? What is man-made? Synthetic. Okay, so natural polymer, what are the examples? We have your latex. Okay, we just learn it. Okay, okay, which one have you heard before? Which one have you heard before? It seems like, what are all these? Right? What are all these? Have you heard of anything before? Have you heard of keratin before? Have you heard of keratin before? This thing is in your hair and your nails. Okay, so if you don't eat enough protein, if you don't eat enough, okay, this thing is made from protein, by the way. If you don't eat enough protein, as in you diet, you try to lose weight, you don't eat, and you lack protein, what's gonna happen? Your hair will start to break easily, your nails will start to break easily. You know when people, I don't, have you dyed your hair before? If you dye your hair, right, your hair becomes really dry. Oh no, good lah. Your hair becomes really dry, and it becomes very, very 毛躁, very frizzly. Okay, why? Because you're breaking the keratin. Okay, because in the hair dye, it's bleach. You are breaking the protein. So dyeing your hair is actually a bad thing. This is natural. Next, what is cellulose? This thing is found in your plant cell wall. You remember what is your cell wall? Plant cell wall. Cellulose is actually your fiber. You know fiber, 纤维. You eat fiber to shit, so cellulose is actually your fiber. Your paper is cellulose. Because paper is made from tree, cellulose. Okay, So synthetic is your nylon. Nylon is used to make string, make rope. You know, nylon绳, nylon. And then we have polythene. Okay, we have propene. All the weird name. These are all synthetic. Okay, so label PQRS. So this is your monomer because it's single. This is your polymer because it's joined up. Okay, so what's the process of R? This is your polymerization. I polymerize the thing. I join them together. So the reverse, we call it depolymerization. Depolymerize. I turn it back. Okay, this one we skip lah. Easy. So match the polymer and the monomers. Protein is made from amino acid. We already know this. Glucose is starch. Rubber is isoprene. What is polyvinyl chloride? The short form we call this PVC. You know what is PVC? You know what is PVC? You know the gray color water pipe? I'm sure your house got this pipe one. PVC pipe. Whenever you see plastic pipe in your house, most likely is PVC. Okay, and PVC can also be used to make leather. PVC leather. This is like the cheap quality leather lah. There it looks like this one. Okay, and I don't know whether you know this. After a few years, right? After a few years, this thing will start to peel. 它会脱皮. And then if your sofa is PVC, it will now look like shit because you can see the skin flaking off. So PVC is not very good quality stuff, but it's cheap lah. It's cheap. Okay, if your wallet or your bag is made from PVC, few years later this thing will start to peel, will start to top one. Very lousy quality. Okay, but cheap mah. Cheap mah. What to do? Okay, and then so this is your chloroethane, because chlorine. Polythene is ethene. Okay, so this is your polymerization. What is happening here actually? This is a monomer actually. These are all monomer. So can you see the double bond here? When they open their hand, they join. That's when they become a polymer like this. Okay, I don't care lah. Not really important. Okay, can you please do question 14? I'll let you do question 14. This is our rubber. Can you please do question 14? Just 14 will do. Just 14. Okay, please do it now. I will give you 10 minutes. Okay, I'll give you 10 minutes. I'll give you the answer later. Okay, do this, try not to refer, try to write it yourself. Okay, I'll see you later. Okay, hello again. I hope you are done. Okay, I'll give you the answer. So, for A, this is your negative charge. B is your protein membrane. C is your rubber molecule. Have you done everything? Did you do everything? It's a very long question. It's a very long question. Did you do everything? No? Okay. It's okay. Then let's look at questions B. So explain the action of acid. You see, they even give you a hint there. Acid is positive. Okay. So we can say acid neutralizes negative charge on protein membrane. Okay. So now the rubber particles collide with each other. Okay, so they collide, and then they will coagulate. 3 marks, 3 points. Are your points like this? Or around like this? If yes, then the answer is correct. Very easy, huh? What you see on your note is how you answer. Okay, so for alkali, this is the reverse. So we can say number 1, alkali neutralizes acid. So negative charges remain on protein membrane. Okay, so the rubber particles repel each other. Okay, so they continue to repel. There's no clumping together. There's no colliding. Okay, D, give a reason why latex in its natural state does not coagulate immediately. Okay, when I tap it out of the tree, why does it remain in liquid? Because it still has the negative charge, right? It still have the negative charge, right? Because of negative. Why is my iPad so weird today? Negative charges on protein membrane. Okay, so rubber particles repel each other. You can write back the same thing. So can you see the answer is repeated? The answer is repeated. So E, predict what will happen if latex is left overnight. Give a reason. Okay, it will, the bacteria produce acid. So now latex, or you can say it will coagulate. No need to say what acid neutralize what lah. No need. This is only 2 marks here. Just keeping it short. Write short answers for you. Okay, next. Take other substance that will coagulate latex. Of course, who coagulates is acid, right? So that's a vinegar. Give one inference because vinegar is an acid. So what will prevent is your soap. Soap solution is an alkali. Okay, it is an alkali. So H, I'm gonna skip on our concern. Operational definition, we skip. So circle the type of acid used in rubber acetate to coagulate. If you are the factory, what do you add to let latex coagulate? You use formic and ethanoic. You don't use hydrochloric because this is too strong. Okay, J, circle the type of alkali used. We will use ammonia. Oh, I forgot to mention this. We will use ammonia to stop the coagulating. Basically, you can find ammonia in your pee. Okay, in your pee. So technically speaking, you don't want rubber to coagulate, you can pee in it. Yeah, sounds disgusting, but it works. Okay, so you know what? I think I'm going to stop here. Next week I will finish this. Okay, so next week please use this bag, huh? We will finish this before we jump to chapter 11. I think you received your chapter 11 notes ready, right? Your September notes. So you keep it beside you first. because next week when we finish this, we'll jump straight to that. Okay, any question? Any question? Are you okay with this? Okay, huh? Easy peasy, huh? Simple, huh? Okay, lah. If that's the case, I will see you next week, lah. Okay, so have a good one. See you. Bye bye.